So in this class, we will discuss about volumetric strain and how it can be calculated in case of a rectangular parallelepiped ball. That is, in other words, you can say when the specimen has got 3 dimensions and it is subjected to stresses in all the 3 directions, x, y and z directions. So volumetric strain is defined as the ratio of change in volume to initial volume. Just like our linear strain or lateral strain, change in the dimension divided by original dimension gives the value of strain. Similarly, volume, if any volume changes take place, then the ratio of that change in volume to initial volume is nothing but your volumetric strain. So in this case, delta V is the change in volume, V is the initial volume. So delta V, if it is positive, it is the meaning that the entire volume of the body has been increased. That means there is an increase in volume. If delta V is negative, it indicates decrease in volume. So the forces may be tension or compression in x, y, z directions. So net effect it will give. So this volumetric strain gives the net effect of the forces on the specimen. Okay. Now this can be found out by using one important law called generalized Hooke's law. So Hooke's law, you know that within elastic limits, linear stress is directly proportional to linear strain. So then that ratio you can take it as that Young's modulus, E is equal to sigma by epsilon, that we have studied. So extension of that is generalized Hooke's law. So we can say that generalized Hooke's law is the combination of principle of superposition and Hooke's law. So when you want to define generalized Hooke's law, I will take a 3-dimensional stress system. 3-dimensional stress system means like this. It is like this. I have taken a solid block made of some material whose Young's modulus is known, E value is known, and whose Poisson's ratio also is known. So E and mu, they are known things here. E and mu are known because it has got both linear effect as well as lateral effect. So these constants for the particular material of the specimen are given. So this specimen is subjected to forces in all the 3 directions, x direction, y direction, z direction. To illustrate this generalized Hooke's law, what I have done is I have considered all the forces as tensile. So usual convention is tensile forces are taken positive and also tensile stresses that are going to develop, they are taken as positive. Whereas compressive forces and compressive stresses by nature, they are considered as negative. So just to understand the concept of this, I have taken Px is the force which is acting normal to this plane, that is Px is the force acting in x direction, it is normal to yz plane. Py is the force acting normal to that this plane, that is you can say it is zx plane, and Pz is the force acting normal to xy plane. Now corresponding, I have taken all the forces as tensile here as already told. Corresponding stresses that are going to develop in those particular directions will be sigma x is given by Px by Ax. What is this Ax? Ax is the area over which this Px is acting. So that is this area. Perpendicular to that force, this area we have to take. So this area is Ax. I have written here. Then sigma y is given by Py by Ay. So Ay is the area perpendicular to this Py. That is this area. Okay. Then sigma z is Pz by Az. So Az is the area perpendicular to this Pz. That is nothing but your Az. That means this into this. So when I take up the problem, you will understand how to calculate those things. So you know that stress is directly proportional. Stress is nothing but resistance force divided by cross-sectional area over which that force is acting. So these directly you can calculate. All these values will be in Newton per millimeter square. I have written here sigma x, sigma y, sigma z. They are in Newton per millimeter square. Forces are in newtons. Of course, if they give in kilonewtons, you have to convert it in newtons. And areas, you have to write it in millimeter square. And volume and change in volume will be in millimeter cube. So here, one thing, if you note observe down is, suppose if the force is compressive in any direction, then corresponding stresses will be compressive stresses and they are taken as negative. That is a sign convention. Now volumetric strain is defined as epsilon V, which is sum of algebraic sum of the strains in all the three directions. So that is epsilon V is epsilon x plus epsilon y plus epsilon z, where epsilon x, epsilon y, epsilon z are the strains along x, y, z directions respectively, and they are given by this. So this is the generalized Hooke's law. So if you note down this, so this is generalized Hooke's law. Using this, we have to compute the volumetric strain, and then we have to compute the change in volume. You can observe here that epsilon x consists of sigma x term, sigma y term, sigma z term also. The meaning of this is, when you are computing the net effect of all the forces acting on the specimen, we have to consider the effect in all the three directions. In the linear direction, for example, you are considering x direction. In x direction, it is sigma x by E, whereas in the other two directions, the effect of that force acting in x direction will be opposite in nature. Just I told you, if it's a tensile force, length will increase but diameter will reduce, or the width and thickness will reduce. That means it has a reverse effect in the other two directions. That is why we have taken negative here. See, when you are finding epsilon x, sigma x we have to take positive, but sigma y and sigma z effect will be negative, and it should be multiplied by Poisson's ratio because we are considering the lateral effect also. So what I suggest you is, when you are writing these equations, sigma x, sigma y, sigma z, we have to take positive if it is tensile stress. I have written here. If it is tensile stress, we have to take it as positive. Suppose if any one of them is compressive, we have to take it as negative. For example, if I say Py is compressive, then sigma y will be compressive and its value should be taken as negative. So that you can see in that problem. Now, like that, after getting these three values, strain in x and strain in y and strain in z directions, due to all the three forces, we are going to calculate the volumetric strain, which is nothing but the sum of these three, epsilon x plus epsilon y plus epsilon z. Now, according to this definition, so if you want delta V, change in volume, so delta V will be epsilon V into V. So this V is the initial volume, which you can compute by knowing the length, width and thickness of the given specimen. So this is the procedure for finding the change in volume. Now let us discuss a problem on this. So in this problem, you can observe that I have taken a compressive force of 200 kilonewton in x direction. Compressive force. You can see the arrow. It is a push force. That I can take it as Px. Then I have taken a tensile force in y direction, 100 kilonewton in y direction. So that is Py. Then I have taken a tensile force in z direction, 50 kilonewton. That is Pz. Now dimensions of the specimen are 500 mm length, 200 mm width, 100 mm depth. So now the question is, E value for this material is 2 into 10 power 5 Newton per mm square, that is steel, and mu value is 0.25. Now this is what he has given. He has asked for the value of change in volume. So this change in volume may be positive or negative, we don't know. Once we get the value of epsilon V, then we can see whether it is, if it is positive, then it is increase in volume, if it is negative, then it is decrease in volume. Now the procedure is very simple. So you write down this Px, Py, Pz. Of course, they are given in kilonewtons. We have to convert them into newtons. We have to stick on to these units. Okay. Now, sigma x is given by Px by Ax. So Px is 200 kilonewton. That is 200 into 10 power 3 Newton. This becomes Newton. Then Ax is the area perpendicular to this. Perpendicular to the area is 200 into 100. That's what I have taken here. So this is in millimeter square. If you simplify, you are going to get 10 Newton per millimeter square. This is compression. C stands for compression. Compressive stress. So I have to take that as negative. That means when you are using the formula, this formula we are using, so we have to take sigma x as minus 10. That's what we have done there. So minus 10 we have to take. Then sigma y. Sigma y is Py by Ay. So Py is 100 kilonewton tension, 100 into 10 cubes. That is in newtons. Corresponding area is this area. See, this is the area. over which it is acting. That is 500 by 200. 500 by 200. It gives 1 Newton per mm square. This is its tensile force, tensile stress. So it is positive. Then sigma z, Pz by Az. Pz is 50 kilonewton. So 50 into 10 power 3 Newton divided by area over which that Pz is acting is this area. Is it done? This is xy plane. So that area is 500 by 100. Okay. If you simplify this, you will get 1 Newton per mm square. That is also tensile because tension force is there. That is also taken as positive. So first you get the values of the stresses in all the three directions. Now once you get the value of stresses, then you can find the strain values. Strain values are epsilon x, epsilon y, epsilon z. They can be found out using this generalized rules or formula. So epsilon x, now be careful here, 1 by e is common, into e you can substitute at the end. Okay, 1 by e is common here in all the three, into sigma x. Sigma x is here in this problem, 10 compression, that means minus 10. I have to take minus 10. Okay, then minus, this is the formula, into mu is 0.25. He has given mu value 0.25 into sigma y plus sigma z. Sigma y is tensile, so therefore it is positive. Sigma z is also tensile, therefore it is positive. So sigma y plus sigma z. If you simplify this, you get minus 10.5 divided by E. Then similarly epsilon y, this formula, 1 by E I have taken outside, into sigma y. Sigma y is tension, that is plus 1. Tension is positive. Minus, in this formula minus is there, 0.25 as usual, into sigma z. Sigma z is, you can see here, tension, that means 1, positive. Whereas sigma x is compression, negative. So minus 10 we have to take. So 1 minus 10, it is not 1 plus 10, it is 1 minus 10. If you simplify this, you will get 3.25 divided by E. Then epsilon z, 1 by E into, see here, sigma z you have got 1 Newton per mm square, which is tension positive. So 1 I have to take, minus 0.25 for mu into sigma x plus sigma y means sigma x will be minus 10 now because it is compression, plus sigma y is plus 1 because it is tension. So if you simplify this, you will get 3.25 by E. Now if you add all these three, epsilon x plus epsilon y plus epsilon z, E is common here. So minus 4 you get divided by E. So this, then you can substitute for this E at the end. So you will get minus 4 by 2 into 10 power 5. That is the value of E given. So you will be getting minus 2 into 10 to the power of minus 5. See here you can see that you are getting negative value. Negative value means it is compressive strain. Compressive strain. That means the volume has reduced. So initial volume V is now 500 into 200 into 100. That is the initial volume. You get 10 power 7 millimeter cube it is. Then delta V, as this formula gives, it is epsilon V into V. So once you get epsilon V, it is minus 3 to 10 power minus 5 into initial volume 10 power 7. You will get minus 200 millimeter cube. So minus 200 millimeter cube means negative sign indicates that is finally there is a decrease in volume. See, in x direction you have compressive force, in y direction you have tension force, in z direction you have tension force. The net effect, total effect is compression. That is, the volume has reduced by 200 millimeter cube. That is the meaning. So now this is a three-dimensional stress system where I have given forces and stresses in all the three directions. Suppose in case if they don't give any force in y direction, then Py will be 0. Corresponding sigma y will be 0. If they don't give any force in z direction, Pz will be 0 and corresponding sigma z will be 0. And the same formula we have to use. In the place of sigma y, sigma z, we have to take them as 0. Other things, sigma x will be there. So suppose if there is no force in x direction, Px will be 0, sigma x will be 0. So other stresses will be if they give other forces, its effect will be there in the other two directions. So same time we have to do. If they give only one force, for example, if they give only 200 kN, so in that case only sigma x effect will be there, sigma y will be 0, sigma z will be 0. In this formula, sigma y, sigma z we have to make 0, sigma y, sigma z we have to take 0. Here also sigma y, sigma z we have to take 0. Sigma x term only will be there. So we have to proceed the same lines and we have to add all of them. to get epsilon V, then multiply that epsilon V by the initial volume, you will get the change in volume. So this is the procedure. Thank you.